Welcome back, students. In this lecture, I'm going to attempt to answer the question of what exactly machine learning is and how it differs from statistics. I think we'll see that there's a lot of overlap between the two concepts. They use a lot of the same methods, but the goal is very different. So let's start with machine learning. According to Wikipedia, machine learning is the study of computer algorithms that improve automatically through experience. Machine learning algorithms build a model based on sample data, known as training data, in order to make predictions or decisions without being explicitly programmed to do so. Machine learning in geospatial applications is often applied in order to classify features. Classification is the problem of identifying to which of a set of categories a new observation belongs on the basis of a training set of data containing observations whose category membership is known. So a classic example is assigning a given email to the spam or non-spam class. For instance, in Gmail, you can assign an email that you get to be spam, and every time you do that, you're providing training data that will help Gmail's machine learning algorithms decide whether the next email that comes in is spam or non-spam. And eventually, the more you do this, the better the machine learning algorithm is, and the more accurate that classification is going to be. And this algorithm may be different for each person. So somebody else may get the same email and not call it spam, and so they may actually see a different set of emails that you end up seeing. A geospatial example might be assigning a land use classification based on a set of attributes such as elevation, slope, aspect, distance from a city, etc. And ideally, the predictors are derived from easily available spatial data, so that they can be applied to a large area without requiring a lot of field work. So how is machine learning different from statistical analysis? Well, again, according to Wikipedia, machine learning and statistics are closely related fields in terms of methods, but distinct in their principal goal. Statistics draws population inferences from a sample, while machine learning finds generalizable predictive patterns. So the short answer is that many of the methods are the same, but the goal is different. For example, linear regression is used in statistics to understand or make inference to the nature of a population based on the properties of a sample from that population. So we're trying to answer the question about which attributes are the most important or significant in determining land use and what are the effect sizes of those. So maybe the most important determinant of land use is distance from a city, and other important aspects are elevation and the amount of rainfall, but maybe some other things like slope is not that important. And the nature of the relationship is also important. So with distance from a city, maybe if you're within 10 kilometers of a city, then that distance makes a difference. But if you're more than 10 kilometers away from the city, then that distance becomes less important. So in this case, we go out and take a bunch of samples, and from those samples, we use statistical analysis to make inference to the process of land use. Now in machine learning, linear regression is used to build a statistical model from known observations. These are known as training data in this case, that allows you to make predictions about unknown areas. So basically, we're only concerned about what is the predicted land use at point X, given what we know about elevation, rainfall, distance from a city, etc. So the process is very similar. We're going out and sampling in various areas, but we're not particularly interested in using a sample to understand the process of land use. What we're really interested in is using those samples as training data that will allow us to make predictions about areas that we haven't sampled. So we're using the same method, but with different goals. So thanks for listening. In the next lecture, we're going to talk more about this course and the data set that we're going to be analyzing and how the course will be laid out. And we'll see you then.